Hey y'all, it's me, Miss B. Today we're talking about graphing sine and cosine equations, but we're focusing on vertical and horizontal shifts. Okay, so just a reminder that we're going to start out with our key points being 0, pi over 2, pi, 3 pi over 2, and 2 pi. And our y values will change depending on if it's sine or cosine. So here we have the points 1, 0, 0, 1, negative 1, 0, and 0, negative 1, where our x values are cosine and our y values are sine. Let me not actually put x and just put theta. No, it was supposed to be x. Huh. Okay. All right. So here we want to talk about our steps to find our x values. The steps are going to be our x values, remember, are inside of the parentheses. And we're going to subtract C and then divide by B. And then for our y values, which are outside the parentheses, we're going to multiply A and add D. Okay, so we're going to look at these parent functions here, or not parent functions. We're going to look at these functions. We already know what the parent functions look like from our previous notes, so you can go ahead and cross that bit out. Okay, so I'm dealing with sine, so my parent function is going to be x, y, and then we have, you know what, let me actually make 2 of these. Copy, paste. Okay, that way we have, it's gonna be a pain, I guess. Okay, that's gonna be as good as it gets because I'm having trouble. Okay, so original x and y. So we start with 0, pi over 2, pi, 3 pi over 2, and 2 pi. And our y's for sine are 0, 1, 0, negative 1, 0. And these values come from the unit circle. Okay, so let's talk about the different shifts that we have. So our amplitude is going to be that a value. There's no a value, or a value is just a 1. Our period, the way we find our periods, we set that stuff inside the parentheses equal to 0 since it's just x. I'm sorry, we set the stuff in the parentheses equal to 2 pi, and because it's just x, it is just 2 pi. So this is x equal to 2 pi. And then finally, our phase shift, we haven't got to that yet, but for now, just say that it's a 0. Okay, so our new function, we are going to have a change in y because of this plus 2. So this is going to cause a change in y. And so we're going to add 2 to each of our y values, and our x values are going to stay the same. And then our y values, we add 2 to these. So we get 2, 3, 2, 1, 2. Okay, so then we're going to graph each of these points. Okay, so we have 0, 2, pi over 2, 3, pi 2, 3 pi over 2, 1, and 2 pi 2. And so then our graph is going to look like so. And remember, it does have a bit of a curve to it. And it does continue the other direction as well. Okay, so as you can see, if we were to highlight this line here, that is where our new center is. So you can see that it's been shifted up 2, and so that is what used to be 0 is now 2. Okay, so this next one here, let's go ahead and create our table. Oh, I wish this would work. You know what? I'm going to put them down here. That'll help. Okay, whatever. That's fine. This is our table down here. So our x and y are, for cosines, we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then y is 1, 0, negative 1, 0, 1, because cosine always starts at 1. And then our transform function, we'll get to in just a second. Let's talk. Our amplitude for this one is 1, because our a is equal to 1. Our period, so we don't have a change in b, so this is no change in b, and so this is just 2 pi still. And then for our phase shift, we're going to set this right here equal to 2 pi, or no, we're going to set it equal to 0, equal to 0, and solve. So we get x equals pi over 2. And what this means, so our phase shift is pi over 2. Now what this means is that our function is going to start at pi over 2 now instead of at 0. Okay, so it's shifting pi over 2. So our x values are changing. We want to subtract c. So we want to subtract, let me rewrite these two values so we can have room. So we're subtracting c, so c is negative, is just negative pi over 2, so we have 0 minus negative pi over 2 minus negative pi over 2. Now subtracting negative pi over 2 is the same thing as adding pi over 2, so I'm going to go ahead and change the 2 in here. And then we have no changes in y. So our x values, 0 plus pi over 2 is just pi over 2. Pi over 2 plus pi over 2 is 2 pi over 2, or pi. For this we get 3 pi over 2. If we get a common denominator, we get 2 pi over 2 plus pi over 2. This one we get 4 pi over 2, or 2 pi. And then finally 5 pi over 2. Okay, so then our y values are the same, so 1, 0, negative 1, 0, 1. And so we're going to plot each of these points. So here I have pi over 2, 1, pi, 0, 3 pi over 2, negative 1, and 5 pi over 2, which is here, 1. Wait, not quite there. Probably more like here. Why doesn't this look right to me? Oh, because 2 pi is supposed to be 0. And then 5 pi over 2 is 1. Okay, that looks better. Okay, so then we want to graph this. Remember, it does have a curve to it. For whatever reason, the graph with sine just kind of bothers me. So I'm gonna show that that is the cutoff, and I'm actually gonna continue it just one more point just so we can see what that looks like. So if you look at this graph, so with the red, what does this new graph look, transformed graph look like? And so I want you to go ahead and write any observations that you have. Now, whatever observations you had, you should have said that it looks like sine of x because look, it starts at 0 and it continues on. So cosine of x minus pi over 2 is actually equal to sine of x. Okay, so you'll find that when we shift stuff around, it might start looking like other stuff because of how similar the functions are. Okay, so let's define these. So a phase shift is how much or far the function shifts on the x-axis. Okay, so we already kind of talked about this, but we set what is inside the parentheses equal to 0. And then we solve for x. Okay, so for this one we have a couple different transformations. You'll notice the 3 and that pi over 6. So let's go ahead and talk about what they do. The amplitude is going to be 3. The period is, we've got a 1 in front of that x, so it's still 2 pi. And then our phase shift, to find it, we set x minus pi over 6 equal to 0 and solve. So x equals pi over 6 is our phase shift. So, I'm going to write our function, I'm going to write our original x's out here just to kind of save us some time, and write our original y's out here. So our x values, if we're cosine for the parent, are, so this is parent and this is parent out here. So for x, it's going to be for cosine 1, 0, -1, 0, 1. Oh wait, that's for y. Huh? It should be 0, pi over 2, pi, 3 pi over 2, and 2 pi, and then -1, 0. Oh, dang it, I keep messing it up. 1, 0, -1, 0, 1. Okay, so gonna take each of our y values and multiply them by 3, and take each of our x values and subtract -pi over 6. In other words, adding pi over 6. Remember that you can just type these into your calculator to add. So like for this first one here, you do like 0 plus pi over 6. So that's pi over 6. For this next one, you'd have pi over, or I'm sorry, 1/2 plus 1/6. and what you end up with is, I think 2 pi over 3. So this is the same thing as 3 pi over 6. So 3 plus 1 is 4, which simplifies to 2 pi over 3. 6 pi over 6 plus pi over 6 is 7 pi over 6. Then we get 10 pi over 6, or 5 pi over 3. Is that right? Times 3 over 3 is 9, 10, yeah. And then 2 pi over 6, I'm sorry, this is 12, 13 pi over 6. Okay, so I'm just adding those together. You can do those in the calculator. And then I'm multiplying each of my y values by 3. So 3, 0, negative 3, 0, 3. So we don't have these values on here. I didn't quite think that through, I guess. So I'm going to go ahead and label these. This is going to be pi over 6, pi over 3. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so then this is 1, 2, 3, wait, 1, 2, 3, 4, 5 pi over 6, 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. So sometimes it'll require you kind of like relabel. Just do your best with that. It's just going around the unit circle. All right, so I'm going to go ahead and graph these. So pi over 6, 3, 2 pi over 3, 0, 7 pi over 6, negative 3, 5 pi over 3, 0, and 13 pi over 6, 3. Okay, so this is our graph. Draw it with some curves. Okay, so you can see that there's a tiny bit that it was shifted to the right. So that is our phase shift of pi over 6. Okay, so this next one here is pretty fun. I think it's our last one, and then these practices are for you in class or at home. Okay, so notice that our amplitude is negative 1/2. Okay, so I'm going to go ahead and write that our amplitude is negative 1/2. What that means is it's going to get squished and it's going to get reflected over the x-axis, but that's not really going to change our math at all. Our b value is 2 pi, so if I take 2 pi and divide it by my b value, I get that my period is 1. And then my phase shift, I have to set what's inside the parentheses, so 2 pi x plus pi equal to 0. Subtract pi from both sides, I get that we get 2 pi x equals negative pi. So then x is equal to negative 1/2 is the phase shift. So we are going to have to relabel our thing down here. All you're going to do is you're going to change oh, that's really large. You're going to change these pi's to 1s is all you're going to do. So this is 3/4. because all we're doing is taking away the pi. So this is 1, 5 pi over 4, 3 over 2, 7 over 4, and 2. Okay, so then these are now 1s. Okay. And then I'm going to go ahead and erase this stuff over here, so we don't need this stuff. Okay, so again, I'm going to put our x values of our parent function and y values on the outside just to save us some time. So we have sine, so it's 0, pi over 2, pi. Let me write this better. Pi, 3 pi over 2, and 2 pi. And then our y values start at 0, 1, 0, -1, 0. Okay. So remember that we have to, with our x values, we need to, I think we need to divide by b and then subtract c is the order, if I'm not mistaken. No, subtract c, then divide by b. So we're going to take our c value, so we're going to minus pi over 2, then we're going to take that and divide by 2 pi for each of these values. So we're going to subtract, let me move this over so we have a little bit of room. So subtract pi over 2, and then multiply by 1 over 2 pi. I think the best way of going about this is just doing it in a calculator. So 0 minus pi over 2 is negative pi over 2. So we get 1/4 for our new x value. Change our color. Then for pi over 2, we subtract pi over 2 and get 0, and then divide by 1 over 2 pi, and it's still 0. Then, did I write our value wrong? Yeah, I did. Dang it. Okay, let's start back here. I was subtracting pi over 2 and not pi, which is why I was confused. Okay, here we go. So we want to subtract pi because that is our c value. So this is our c value and this is our b value. So we are going to subtract b and then, I'm sorry, subtract c, then divide by b. There we go. Okay, so subtract pi, divide by, or multiply by 1 over 2 pi, and we get negative 1 over 2. Then we subtract pi, get negative pi over 2, multiply by 1 over 2 pi, we get negative 1/4. Pi minus pi is 0, and so we get multiply by 1 over 2 pi, that's still 0. You'll notice a pattern where we're just adding 1/4 each time. So you can continue on with that pattern, or you can keep doing the equation. I like to just follow the pattern because it saves me time. and math. Okay, and then our y values, we're going to multiply by negative 1/2. Okay, so we get 0, negative 1/2, 0, positive 1/2, 0. Okay, so let's graph these. So I get negative 1/2, 0. Oh, negative 1/2 would be 2 ticks this way. This is 1/4. Okay, then we get negative 1/4, negative 1/2, 0, 0, 1/4, 1/2, 1/2, 0. So our graph looks like so. It keeps continuing on in both directions. Okay, so that's it for our examples today. Go ahead and rate 1, 2, 3 how you are feeling about this stuff. So 1 would be I get it. 2 would be I need Miss B's help. And 3 would be I'm totally lost. Okay, that's it for today, folks.